Hi everyone, welcome to our third lesson in grade 9 science, physics, electricity. We're looking at static electricity, and today we're going to be looking at charging by contact and how it's possible to transfer a static charge onto an object. But first we need to get a static charge built up, and so to do that we're going to use a rubber balloon and either my hair or a wool sweater. So here's the rubber balloon on our electrostatic series. And here's human hair or wool. And as we talked yesterday, you'll remember, electrons fall down the electrostatic series, right? So whether we use wool or we use human hair, the human hair and the wool is going to end up with a positive charge. And the rubber balloon is going to end up with a negative charge. So we can draw that if we had a balloon and we had a sweater. If they were rubbed together, the electrons from the wool sweater would transfer to the rubber balloon, and you'd end up with a negative static charge on the rubber balloon and a positive charge on the sweater. Okay? So what we're going to do now is we're going to use what's called a pith ball to demonstrate charging by contact. So what we're going to do, or what we're going to need to do first, is look and see what is a pith ball. All a pith ball is an insulated sphere that's hanging on the end of a very slender string. So a pith ball is an insulator that can accept a charge or lose electrons. And in this case, our pith ball is going to accept a negative charge and will collect a charge on its surface. So this pith ball is insulated from the rest of the environment by this very slender string. So I'm going to show you a video right now that shows how this happens, and I'm going to show you it being charged by contact, and let's take a look at that video. Okay, this is a pith ball, and really all it is just an insulated object that will hold on to a charge, a static electric charge, once we put the static electric charge on it. So what we have here is a styrofoam ball that I have wrapped in aluminum foil and then hung with a very thin thread so that none of the charges that go onto it will be able to escape the pith ball. So what I'm going to do is I'm going to take this purple balloon and I'm going to, as we talked about, rub it on my hair and charge it up. So my hair is losing electrons, the rubber balloon is gaining electrons, and so now the rubber balloon has a negative charge. And if we bring it to the neutral pith ball, we know it should be attracted. And you can see it's attracted, and then parts of it start to do something strange in a minute. Once we have a charge all over that pith ball, I'm going to charge the balloon again and add some more charge to it. You'll notice that it doesn't seem to like the balloon sometimes, and then sometimes it does. We have to get a full and complete charge on it. But you'll notice that sometimes the charge on the pith ball repels the negative balloon. And the reason for that is because suddenly we have charged the pith ball with a negative charge, and like charges repel each other, and you can see that it sometimes will swing away once the charge is great enough. And sometimes it attracts because we're losing charge. It's a little bit of a humid day, and static electricity doesn't work all that well when it's humid. There we go. So if I bring a strong negative charge towards this negatively charged pith ball, or it will gather, when it contacts, it will sometimes gather the same negative charge and bounce away, just like that. Let's do that one more time just because it's kind of fun. And you can see it's being charged by contact, and then the same negative charge is being transmitted to the pith ball, and it's bouncing away. Okay, so now that we have seen charging by contact, let's take a look at what's going on here. So initially, we had a neutral pith ball, and our neutral pith ball had the same number of positive and negative charges, and we brought near it the balloon, and that balloon we had charged up, so it was negative, and it had a negative charge on it. So we can draw that here, and we can show a whole bunch of negative charges. Those negative charges repel each other, and they don't like to hang out together. So when we actually brought that balloon in contact with that pith ball, those negative charges were looking for a place to go, and they jumped onto the pith ball. And as you saw, as soon as they had done that, there was still some negative charge on the balloon. Then there was a negative charge on the pith ball, and it repelled and it moved away from the balloon. So in the end, we had a negative charge on the pith ball and a negative charge on the balloon. And that's really important. When you're charging by contact, you'll find that you end up developing the same charge between the two objects, which is different from when you're charging by friction, of course. Let's just do a little note to explain that. If we had a wool sweater and another piece of fabric, one of them would end up with a positive charge, while the other one would end up with a negative charge. However, if we're charging by contact, and you can imagine a contact situation where you have charged your body up with a lot of negative charges just before you touch something like a doorknob, those charges obviously flow over to the doorknob, and you end up with a very negative doorknob. Your finger is negatively charged, the doorknob becomes negatively charged, and so when we are charging by contact, we end up with charges that are the same. So let's write that out. We have different charges. Being developed with friction between the two objects after the interaction, and we end up with the same charges being developed after the interaction. Okay, so that's the end of today's lesson.